every practically possible way to render fast in Blender. Well, let me tell you that you can render an image which takes 1 hour to literally 1 second. But the quality you see is barely usable. This is where the question comes about practicality. So this is what the video is about. So without wasting time, let's get started. So starting with the most obvious one, reducing polycount. Any model that you have in your 3D scene consists of polygons. In this scene you can see there are 3.3 million polygons. You can see this by right clicking at the bottom and show scene statistic. So this face is one polygon. So the more polygon, the slower it will render. So usually we use the subsurface modifier to smooth the geometry, but a single subdivision increases the polycount by 4 times. So set it to a minimal level possible until it makes a drastic change. If it doesn't make change at all, it's better to remove it. So you can see just by reducing one level of subdivision of all objects, I have managed to get 1.3 million polycount. But let's say that you are not using subsurface modifier, but you still want to reduce the polycount. So you can use the decimate modifier to reduce it, and you can see the number of polygons the model has. So this bar is like a percentage. Reducing it will reduce the polycount. But don't overdo it because it downgrades quality. Applying it will take changes, but your topology will get messed up, so keep that in mind. Texture resolution is another most forgotten aspect when it comes to rendering. But what is texture resolution exactly? Well, when you download a texture from the internet, you can see the sizes like 1K, 2K, 4K. These are texture resolutions. The higher it is, the higher it will take GPU memory and the slower render times, and 4 times the difference between the memory of this resolution. So usually I use 2K texture. Using 4K or 8K is no brainer for me and my system. And you can barely find any difference in 2K and 4K unless the object is very huge. But let's say that you have a texture that is really high res and you want to downgrade it. Well, it is possible in Blender. In shading tab, you can select a texture and it will appear in the image editor. Then click here and click resize and divide it by 2. That's all. You can assign it a shortcut as well. I have set it to numpad asterisk. Well, it's a bit time consuming optimization, but it's worth it. Whether you are using particles or geonodes, the more instances, the more time it adds up to the render time. So it's obvious to reduce the number of instances in the scene or only spawn instances where only the camera can see. You can even create 2 geonodes or particle system where one will be in the foreground with higher density and one will be in the background with lower density. Disabling shadows is another way to reduce render times. This is useful when you have too many tiny objects but their shadows are not contributing to the overall scene. You can disable shadows by selecting the object and go to object properties and under ray visibility, uncheck shadows. I generally do this to the objects that are far away from the camera. Let's say that you have an object that's like a concrete or any man-made stuff. Will it be transparent or shiny? Of course not. Same thing is used to happen in our 3D scenes. You can see that this object is contributing to the glossy and transmission pass, which is clearly unnecessary. This creates complicated calculation and thus increases render times. Turning the unnecessary passes off will help really well. For those who don't know, FPS means frame per second. But I know that everyone knows it. FPS do matter in render times. How? Let's see. Say you have to render a 5-second animation. So if you were to render it at 30 FPS, it would take 150 frames to render. But if you are rendering it at 24 FPS, it would take 120 frames to render. Consider that one frame takes 1 minute, so you have saved half an hour on the animation. So before rendering any animation, ask yourself if it's worth rendering at higher FPS. Always bake all the simulations or rigid bodies. This will help in faster processing for renders. Thus, we'll have significant difference in the render times. You can do that by selecting the domain and go to bake and set that to all. And select the frames and hit bake. For rigid bodies, select the object and go to Object dropdown and select Back to Keyframes. Well, this might sound a little bit odd, but metallic or glossy materials take more render time than a material with roughness. This is because it has to calculate reflections. So try to use as much rough materials as you can. While creating a 3D scene, we test many different materials, objects and whatnot. But do you know when you delete them, they get stored in the blend file and hence take more memory. Kind of like a recycle bin, which makes the overall scene slower. So to delete those unused data, go to View Layer and select Orphan Data. This is all the data that is not currently being used. So to delete that, scroll to the right and click Purge, and all the unused data is now gone. Transparent materials are a lot difficult to render as compared to normal material. So try to minimize the use of transparent materials. If you are using images as planes, then you can cut the image with the knife tool and remove the alpha from the BSDF. Subsurface scattering is another material that is a lot harder to render for cycles. Subsurface scattering actually acts like a human skin which can let light inside it and make this really great looking effect, but at the cost of time. If it's really necessary, try only using it for the main subject of the scene. The more lights you have in your scene, the more calculation cycles has to do, hence increasing render times. Also, the higher the intensity of the light, the more time it takes. So this is not very significant, but it does matter. And you will be surprised that among the 4 lights we have in Blender, Spotlight renders the fastest. I think this is because the smaller spot area of the light. So if you are not used to with Spotlight, give it a try. I don't know why, but every render engine in this world has this weakness where if your overall scene is white, it will render slower, and if your overall scene is black or darker, it will render a lot faster. You can even see in my viewport that the scene with white color takes 3 seconds to denoise, while the black one does not even take 1 second. And also do not use a perfect white color because it's a lot harder to render, and also perfect white does not exist in the real world. Let's say you have an object with X number of polygons and you want to duplicate it. So you will press Shift D and you will see the amount of polygon have doubled as well. Actually, there's a way that you can keep the polycount same while maintaining duplicate objects. So instead of pressing Shift D, press Alt D and you can see that polycount is still the same. Well, this duplicated object is known as instance. The only downside of instance is that if you edit any instance, it will edit all instances at the same time. So I recommend instancing only when you are completely done with an object that you will not edit anymore. This could be a little bit obvious, but for those who don't know, GPU renders a lot faster than a CPU. So if you have a GPU, then go to Edit, Preferences and System. You can see here GPUs of different configuration. I have an RTX card that uses optics, so I will select optics. And most of the Nvidia cards works with CUDA, so you can select that. You can find more info on the internet. The only component you need to upgrade to render fast is GPU. Well, that's completely wrong. Actually, RAM and processor plays a huge role as well. When you have many modifiers, particles or simulation, they are being processed by the processor. This can be seen when you hit F12 to render. You can see text like synchronizing object or calculating BVH appearing for some time. And sometimes it took me 1 to 2 minutes just for processing. So a higher RAM can handle scene better and a great processor can do the processing jobs quickly, hence decreasing the render time. So keep that in mind. Adaptive subdivision is a method that creates detailed subdivision near the camera and less detailed subdivision in areas away from camera. This helps in optimal subdivision of the object, which decreases render time significantly, and if you are using subdivision surface quite often. To enable that, go to render settings and change that to experimental. Now you will see that every subdivision surface modifier has an option called adaptive subdivision. Check that box to enable it. Now this noise threshold is a game changer. but if used wrong, it can destroy your renders. But what is noise threshold exactly? So noise threshold is a value that acts as a filter that allows noise to be rendered which is above its value and blocks noise that's below it. In simple words, the higher the noise threshold value will be, the worse quality you will have, but will have quicker results. And the lower value, the better quality you will have, but the longer it will take to render. Higher values are generally useful when the scene is really simple with no complicated shadows, no volumetrics, etc. But with much more complicated or realistic scenes, higher value can give pretty trash results, especially while rendering animation. And honestly speaking, I never go above 0.05. You can go higher, but I don't recommend that. Generally, for me, 0.01 is usually best. Sample count is the number of quality steps taken to finish a render. A lower sample count will give blocky and painterly look, which is awful of course. The more sample count, the better quality. Generally for still renders, I use a sample count of 1000, and for animation I use sample count of 500. But in some cases of rendering environments, I have to go to 1000 samples for animation because sometimes a lower number introduces glitches and flickering. Time limit is the time limit of render time excluding the processing times. So you can set the timer to be, let's say, 50 seconds, and it will render the image in 50 seconds or less if the samples are rendered faster. So this is quite handy in some situations. In Blender, there are two ways to denoise a render: open image denoise and optics denoiser. If you talk about speed, optics denoiser is way faster than open image denoise, but in terms of quality, I think open image denoise has the upper hand. But don't worry, that's not a significant difference. I myself use optics 90% of the time. Fast GI approximation is actually a pretty good option to reduce render time. GI, which means global illumination, is a process that simulates indirect lighting for more realism. So fast GI approximation does the GI job as quickly as possible. And do not underestimate this feature. In some cases, this can be a game changer. So to enable it, go to render settings and under light paths, you can see it's here. Now if you enable that, you can see that the scene gets a little bit darker. In some cases, it's not even visible. So if it does not bother you, you can get a significant render time improvement. Fog, aka volumetrics, is a great feature in Blender that's allow you to create lifelike atmospheric effects, but at the cost of super long render times. So if you're rendering a scene that is rendering really slow and has volume, well, the first thing you can do is to delete the volume object. An alternative to volume can be the mist pass using the compositor in Blender, or using a plane with a gradient texture is also a great option I often use. But let's say that you still want to use volumetrics. Well, there's an option to optimize volume as well. In the render setting under volume, you can see the step rate. The above one is for render and the bottom one is for viewport. So the higher the step rate, the lower quality volume you will get, and hence decreasing the render times. And lower number will increase quality but increase render times. Now in my experience, if you're just doing a still render, you can increase the step rate all the way up to 10. But if you're doing animation, try not to go above 5 as it can introduce flickering volume. This is a nice little handy option for rendering volumes faster. But this only works when you are not animating the density of the fog or adding any texture to the density. You can find this option in the material settings and under volume, check homogeneous volume. Let's say you have a super complicated procedural material and because of that, you are getting longer render times. So it will be best to just convert it into a texture and apply it to the object, right? Yeah, of course. This is known as texture baking. Texture baking might take a little bit effort, but it would be worth it if you are rendering animations. Do you know that you can transfer the detail of a high poly object to a low poly object, thus reducing poly counts and increasing performance at the same time? Well, you can watch my video on this on how to do that, and I promise it's really great. The Simplify tab is great as it can put a limit to the subdivision, texture and particles of your scene. You can find it in the render settings and check Simplify option. In here you can see a couple of options. So let's say that you have many objects in your scene that has a subsurf modifier, but you want all of them to be rendered at a subdivision level of 2. So you can set the max subdivisions to 2. So then if you render your scene, all the objects will be rendered at a sub level of 2. And same for the texture resolution and for particles as well. I know it's hilarious to think that even a file type matters. Well, it actually does. Blender gets a hard time while saving PNG images. Instead, if you save your images as TIFF or EXR, it will save it quickly. But TIFF and EXR have large file size, so if you have storage issues, take note of that. Motion blur is kind of a trail of an object that is moving fast. This creates a realistic effect of motion as it also happens to our eyes. But it does increase a little bit render times, which becomes significant while rendering a whole animation. Instead, try using vector blur in Blender's compositor and you will easily find a tutorial on it on YouTube. Persistent data is a bit hidden in Blender. That is useful for rendering animation. What it does is it calculates all the prerequisite data of the scene in the first frame, thus leaving the other frames rendering effortlessly. This can make a huge difference in render times with longer animations. I recommend to have it enabled if you are rendering animation. And also it takes more memory usage than usual, so you will not be able to use other programs while rendering. Reducing modifier count can speed up the early process of the renders. So if your object is finally ready to render, you can apply the modifier that will relieve Blender from memory usage, or sometimes stacking up modifiers can lead you to run out of memory. The HDRI we use to light our scene can have huge difference in render times. Normally I don't use HDRI for backgrounds because I use images. So going over 2K will be a no-brainer for me. So I would say it depends on your needs, but generally 2K is a baseline. If you are using materials with displacement, it's most likely to increase render times. To optimize displacement, you can either use displacement on a particular area using vertex group in the displace modifier, or use parallax displacement, which we also call bump only displacement. Let's say you want to duplicate the whole collection, but as with duplicated objects, duplicating collection will also double the amount of data and memory in the scene. So just like we were using object instances, you can use collection instance to save memory and render times. To add collection instance, go to add collection instance and select the collection you want to instantiate. Also, if you make any changes to the original collection, same changes will take place to all instances. And also collection instances are non-editable. Subdivision dicing rate is the value of subdivision detail of adaptive subdivision. You can see this setting if you have turned on the experimental feature in Blender, and under subdivision drop down, you can see the value in actual render is 8 times lower than the viewport. The lower number, the more detail. So if you are satisfied with what you see in the viewport, you can set the render value to 8 as well, thus reducing render times. Rather than making the whole background yourself from scratch, you can use background images or transparent image planes to create your background. Not this only decreases render times, but saves you a lot of time as well. And in my experience, no one can even notice that they are images. Same as backgrounds, instead of using smoke or fire simulations, you can use transparent stock footages to save render times. To import footage, as you import images as planes, do the same, just instead of a photo, select a video. And that's it. Well, this is quite rare in some cases, but overlapping geometry can create long render times, because the light bounces inside them many times, which creates unnecessary calculation, and if there are many of them, then it could lead to disaster. So avoid overlapping geometry. Light path indicate the maximum number of light bounces in the scene, which are separated by each material characteristic. You can find this in render settings under light bounce drop down. So the total bounces indicate the global illumination. The higher it is, the better global illumination it will have. Diffuse indicates the color bounces, glossy indicates the reflective bounces, Transmission indicates the bounces of materials such as glass. Volume, of course, indicates volume, and transparent indicates the quality of transparent objects. Normally, you won't notice the difference if you set the bounces to 6, and if there are no glass or transparent objects in your scene, you can directly set them to 0. These settings depend on your scene, so try testing them. Now, if you scroll down, you can see caustics, which are really performance heavy, and 99% of the time you will never use this. And even if you want to, you can create fake caustics which looks like real caustics. So just disable it. So that's all the practically possible ways I think of fake render times. Definitely tell me in the comments if they worked out or not. And I will see you in the next video. Bye bye.